This meeting is being recorded.
Good evening. Welcome to Cornerstone Home Inspector Education Center. Tonight we have GFCI Outlets and the 2023 Electrical Code Revision. We're going to go over essential updates that you guys need to know about. We're going to talk about ground fault circuit interrupter protection and the latest National Electric Code requirements. Again, try to keep your microphone mute. And if you have any questions, just unmute it and just break in and we'll answer any questions. Certificates will be emailed out tomorrow morning. You should get them by noon. And then if you don't get your certificates, as always, check your junk and spam folder first, and then just email me. Literally email me that day by the end of the day if you don't get it, because you're going to get them. Okay. Let's talk about state standards. So Connecticut requires inspection of a represented number of fixtures, switches, receptacles, and GFCIs, while excluding measurements of amperage, voltage, or impedance. Massachusetts requires testing the polarity grounding of a represented number of receptacles and operation of all readily accessible GFCIs, while excluding probes inside panels, most overcurrent device operation, and AFCI testing. Rhode Island requires testing polarity grounding of a represented number of receptacles and a sample of readily accessible GFIs. And its 2025 bulletin clarifies that plug-in receptacle testers and GFCI test buttons are permitted, but internal access to panels, outlets, devices, or fixtures should be avoided. And there's a fine if you do open up the panel. I believe it's $1,500. New York requires observing and reporting on a represented number of installed light fixtures, switches, receptacles, and GFCI, but does not require testing of every switch, receptacle, or fixture, removing outlet covers, activating non-energized circuits, or measuring electrical values. New Jersey requires inspection of electrical systems components, including at least one installed fixture, switch, and receptacles per room, and one exterior fixture, switch, and receptacle per side of the house, plus GFCIs. So all the states have representative numbers. When I'm in a house, try to check as many outlets as I can get to. You sort of know when you go in, if it starts out bad, start testing every single outlet because it's not going to get better. So your guide to modern GFCI inspection standards. The ground fault circuit interrupters remain one of the most critical electrical safety components you'll evaluate during residential inspections. The 2023 NEC has introduced significant changes that affect how we inspect, report, and recommend GFCI protection in homes across America. Today's webinar equips you with the knowledge to confidently identify GFCI requirements, recognize common defects, and communicate updates to your clients with authority and clarity. What we're going to cover today is GFCI function and inspection procedures, common field defects, the updates to the NEC 2023 code, and real-world application. So we're going to understand how these life-saving devices work. We're going to identify the most frequently encountered GFCI issues. We're going to review the codes, and we're going to translate code changes into practical inspection reporting and client communication. Why GFCIs matter in your inspection? GFCIs prevent approximately 80% of electrocutions in residential settings. They're not just code requirements, they're essential safety devices that protect homeowners from potentially fatal electric shocks every single day. High value inspection item. GFCI's defects represent some of the most straightforward yet impactful findings in your inspection reports. Missing or malfunctioning GFCI protection is easily explained to clients and clearly demonstrates the value of professional home inspection services. To let you guys know, we did a little research. The modern GFCI was developed by Charles Dalzell, a professor of electrical engineering at the University of California, Berkeley. His work helped create one of the most important electrical safety devices used in the home today, designed to reduce the risk of serious shock and electrocution. I remember, I don't know if Scott seemed to have drifted off, but I remember going to some continuing education about GFCIs, and the instructor telling us that the person who invented it used to go to open, to different manufacturers with a bucket of water, a live electrical outlet connected to a GFCI, and put his foot in it. So that's how he was testing it, just to prove that it worked. Okay, GFCI basics for home inspectors. Understanding the fundamental of ground fault circuit interrupter operation is essential for accurate inspection and reporting. So we're going to break down how these devices work and why they're indispensable in modern electrical systems, residential systems. What does a GFCI do? A ground fault circuit interrupter is an electrical safety device designed to protect people from serious injury or death caused by electrical shock. It continuously monitors the flow of electricity through a circuit, comparing the current going out to the current returning. When a GFCI detects even a tiny imbalance as little as 4 to 6 milliamps, it assumes that the current is escaping the intended path, possibly through a person's body. The device immediately cuts power to the circuit, typically within 25 to 30 milliseconds, fast enough to prevent a lethal shock. This split-second response makes GFCIs one of the most effective electrical safety innovations in residential construction history. So it's a signal, it's going to detect that interrupted supply of the power through moisture. So how does it work? It has to have, we have a balanced flow, a fault is detected, and a trip is interrupted. The GFCI contains a sensor that continuously compares the amount of current flowing through the hot wire to the amount returning through the neutral wire. You can think of the neutral wire as a path where the electricity goes. We're not taking all the amperage from it, just a little bit. In a properly functioning circuit, these amounts should be equal. Any difference indicates current is leaking somewhere, potentially through water, a damaged appliance, or a person in contact with an energized surface. Types of GFCI protection. So we have the GFCI receptacle, the most common type installed at the outlet location. Easily identified by test and reset buttons, can protect downstream outlets when wired properly. We have a GFCI breaker installed in the electrical panel to protect the entire circuit. Features a test button on the breaker itself, useful when multiple outlets need protection. Dual function AFCI GFCI combines the arc fault and ground fault protection in a single breaker, required in many locations under the NEC standards for comprehensive safety. Then we have our faceless GFCI devices located in concealed areas like basements or crawl spaces, maybe inside junction boxes or behind blank covers. Requires careful inspection to locate. As a home inspector, you'll encounter various GFCI installation methods depending on the age of the home, local code enforcement history, and renovation patterns. Receptacle GFCIs are the most visible and straightforward to test during your inspection walkthrough. Breaker type GFCIs protect the entire circuits and may be the only indication of protection for outlets that don't have a test reset button. Always check the panel for the GFCI breakers when the outlets are required and locations appear to be a standard receptacle. Dual function devices have become increasingly common in newer construction. Combine arc fault protection with ground fault protection to meet multiple code requirements with a single device. So your GFCI receptacle, my understanding is that's going to last anywhere from 8 to 10 years. They can obviously go longer. The older ones, you're going to find that they freeze up and they don't trip in the proper manner. The GFCI breaker will last longer. I don't tell people it's more reliable. I just say it's just it's in the panel. You've got to go downstairs if the panel's downstairs to reset it, but it will last longer. Dual function GFCIs, I don't run into those a lot. And of course the faceless. Okay, let's keep going here. If you're viewing this as a pre-recorded event, your viewing code is GFCI 2026. Standard GFCI locations and residential inspections. Before diving into the 2023 code changes, it's essential to understand where inspectors have traditionally expected to find GFCI protection. These locations have evolved over several code cycles, and many homes built before recent code updates lack protection in areas now considered standard. Kitchens, bathrooms, laundry areas, garages, unfinished basements, and exteriors. So when we're in the kitchen, all receptacles serving countertop surfaces. This has been a requirement for decades and is one of the most commonly tested locations during a home inspection. Bathrooms, all receptacles in bathroom areas, no exceptions. This includes powder rooms, master baths, and any space with a toilet sink or bathing fixture. Laundry areas, receptacles within 6 feet of laundry sinks or washing machine locations where water and electricity are in close proximity. Garages, all the receptacles in attached and detached garages, with limited exceptions for appliances not readily accessible or dedicated equipment. Unfinished basement, receptacles in unfinished areas, particularly those within 6 feet of sinks, laundry areas, or plumbing fixtures, expanded in 2023. And exterior outlets, obviously, all outdoor receptacles accessible at grade level. This includes outlets on decks, porches, patios, and anywhere outside the dwelling envelope. Kitchens, we all remember that used to just be right by the kitchen sink. Then it was 6 feet. Now it's every single outlet. Bathrooms, every single outlet's easy. Unfinished basements, when I'm inspecting, I look for one GFCI outlet. I'm changing that in my report after this webinar. So I would want all the outlets in a basement to be GFI protected now. In a basement, that's what I'll put in my reports going forward. Additional required locations, crawl spaces, wet bar sinks, boathouses, rooftop locations. So any receptacle installed in the crawl space area requires GFCI protection due to potential moisture exposure. Wet bar sinks, receptacles within 6 feet of a wet bar sink following the same logic as a kitchen. Boathouses, all receptacle and boathouse structures where water and electricity create elevated risk. Rooftop locations, added in recent code cycles, rooftop receptacles for HVAC equipment and maintenance access. 6-foot rule. We talked about this just briefly. One of the most consistent GFCI requirements across multiple code cycles has been the 6-foot rule. Any receptacle installed within 6 feet of a plumbing fixture must have GFCI protection. This applies to sinks, tubs, showers, and other water sources. As an inspector, carrying a measuring tape to verify distances when outlets near plumbing fixtures lack GFCI protection. Document measurements in your report when making recommendations for upgrades. Basically, this is a little outdated. Like we just talked about, all the outlets in a kitchen, in a bathroom, in the crawl space, in the basement really should be upgraded to GFCI protection. Inspection focus areas. Your value as a home inspector often shines when evaluating older homes that haven't received electrical upgrades. Many properties built before 1970 have minimal or no GFCI protection, even in wet locations. These represent clear safety concerns that should be documented and recommended for correction. Aging homes without upgrades, you want to look for original electrical systems lacking GFCI protection in areas now considered standard. Document the year of construction and note requirements have evolved. Improperly wired receptacles. Test downstream outlets to verify GFCI protection exists properly. Miswiring can leave seemingly protected outlets without actual protection. Failed testing results. GFCIs that don't trip when tested indicate device failure. These should be reported as immediate safety concerns requiring replacement. So as a home inspector, aging homes without upgrades, so we're going to note it in the report, and a lot of the questions we'll get from our clients are, well, doesn't it have to meet today's standards? And the answer is no. In a residential transfer of property, you do not have to bring the house up to code. So, they didn't have I did a house today that was 1795. They didn't have GFCI protection back then. Now, the house has been upgraded, but let's say it was just a 2-prong outlet. We're going to put it in the report that it should have a, GFCI protection, but the end of the day, if the seller does not want to upgrade that, they're not required to. Um, Improperly wired receptacles, I do training. I'm a supervisor, so I will have interns, and they will say, all the other outlets are GFI protected. I tested this, and I don't see any other buttons, so I make them test every single outlet. And sure enough, there's always one that's not connected. And then the GFCIs that don't trip, they get old, and they freeze up and they don't reset. I've made it a habit of, if I'm in a garage and there's a freezer with $5,000 worth of meat, I'm not testing that GFCI outlet. There's just no way, because I'm not buying them a whole freezer full of meat. So we'll talk about that as we go along. The 2023 NEC GFCI revisions, what home inspectors need to know. The 2023 electrical code introduces the most significant expansion of GFCI requirements in over a decade. These changes affect how inspectors evaluate electrical systems, write recommendations, and communicate safety upgrades to clients. Understanding these revisions positions you as a knowledgeable professor who stays current with industry standards. So, key change number 1, voltage range expansion. Previous requirement, GFCI protection was primarily required for 125 volt, 15 and 20 amp receptacles in specified locations. Higher voltage circuits often received exemptions. The 2023 requirement, GFCI protection now extends to all 120, 250 volt receptacles in many locations, regardless of amperage. This includes outlets serving 240 volt equipment. This expansion means that outlets for electric dryers, ranges, and other high voltage appliances may now require GFCI protection depending upon their location. As an inspector, this changes how you evaluate laundry rooms, kitchens, electrical ranges, workshops with a 240 volt tool circuit. So, when a range has to be on a GFCI, that's obviously going to be in the electrical panel. So you're going to want to look for that. Key change number 2, appliance protection requirements. One of the most significant shifts in the 2023 NEC involves extending GFCI protection to specific hand-wired and plug-in connected appliances. This represents a major departure from previous code cycles that primarily focus on receptacle locations rather than specific equipment. So sump pumps now require GFCI protection in most installations. This addresses concerns about water exposure and shock hazards during maintenance or flooding events. Dishwashers, GFCI protection required for dishwasher circuits, given their proximity to water sources and plumbing systems. This change enhances kitchen safety significantly. Electric ranges. In certain scenarios and locations, electric range circuits now fall under GFCI requirements, particularly in installations near sinks or island configurations. Inspection implications. These appliance-specific requirements create new considerations for home inspectors. During your inspection, you will need to identify whether appliances have GFCI protection, either at the receptacle, at the breaker, or through a dedicated GFCI default on the circuit. When inspecting kitchens, test the dishwasher circuit for GFCI protection if accessible. For sump pumps, verify the circuit is protected, though you should note in your report that testing may be limited to prevent water backup during the inspection. Remember, older homes with these appliances installed before 23 aren't required to meet current code, but recommending upgrades for enhanced safety demonstrates your commitment to client protection and protects you as a forward-thinking professional. So when Scott, Stan, and I were putting this together, I addressed the sump pumps. When I inspect and I don't see a GFCI outlet on a sump pump, I do point it out in my report, obviously, because it needs to be. But I too tell my client, it's not going to be in the report, but I'm going to tell you personally, you may not want to have a GFCI outlet on a sump pump. The moisture coming up could trip it. Just the high moisture in a basement can trip it. So I always want my sump pumps running. Now, saying that, as a home inspector, I have pulled the float device up and gotten shocked. So it's not a big shock. It's not fun, but I go back and forth with this. I note it in the report because it's the right thing to do. But at the end of the day, if I had a sump pump in my house, probably would not be on a GFCI outlet. Dishwashers, I have no problems with. Electric ranges, I have no problems with. They should be what they're going to be.
To get back to the sump pump for a minute, or actually any GFI, they developed audio GFIs that kind of beep like a smoke detector. And they're used in locations where you're probably you're gonna be far enough away not to hear it, like the sump pump. But that's my point exactly. If that sump pump's in your basement and you're 2,500 square feet away, if that thing's tripped, you may not hear it anyways.
Right. Or what if you're on vacation and it trips?
Or then your basement floods.
Yeah. So,
But it's just like a doctor when if you see these medications on TV being advertised on TV with all these potential side effects, and you question the doctor about it, he's going to say the benefits outweigh the risk,
right.
and that's what we're talking about right now.
Risk benefit. A lot of these sumps now, the newer ones, especially the basement system ones, have a battery backup, and they don't always come on GFIs.
I recommend every sump pump have a battery backup. Recommend. It's not a requirement, but I just let people know that it just saves them a lot of headaches if they had one.
So
some people have generators.
Stand out.
Key change number 3. Thank you for that, Stan. Outdoor deck and pool requirements. Clarified protection standards. The 2023 NEC removes ambiguity about outdoor receptacles on decks, porches, and balconies. Previous code cycles created confusion about whether elevation above grade provided exemptions from GFCI requirements. Under the updated standard, all receptacles require GFCI protection regardless of the height above grade. This includes outlets on second-story decks, elevated porches, and balconies at any level of a dwelling. Outdoor elevated spaces present unique electrical hazards. Rain, snow, humidity, and condensation create moisture exposure. Homeowners use power tools, holiday lighting, and outdoor entertainment systems in these areas, often while standing on wet surfaces or handling wet equipment. The clarification of the 23 code eliminates the previous gray area where some jurisdictions interpreted elevation as a reduced shock risk. Modern standards recognize the electrical shock hazards exist regardless of height above ground. Inspection action: test all outdoor receptacles during your inspection, even those on elevated structures. Document any lacking GFCI protection and recommend upgrades. It's all pretty simple. They have to have the waterproof cover nowadays. So I put that in the report. Key change number 4, indoor damp and unfinished locations. The 23 NEC provides expanded clarification regarding GFCI requirements in damp or unfinished indoor locations. Previous editions focused heavily on proximity to sinks, plumbing fixtures, and sometimes creating uncertainty about other damp areas. Expanded definition: GFCI protection is required in indoor damp locations, even when receptacles are not directly adjacent to sinks, obvious water sources. This includes areas prone to moisture condensation or water intrusion. Unfinished spaces: receptacle and unfinished locations where walls, ceilings, and floors are not completed require GFCI protection. This recognizes the increased likelihood of water exposure and unsafe working conditions. Practical application: as an inspector identifying partially finished basements, utility rooms with exposed framing, and storage areas where moisture may accumulate, recommend GFCI protection for all these receptacles in these spaces. Key change 5, all unfinished basement receptacles. Perhaps one of the most impactful changes for home inspectors involves unfinished basement requirements. The 2023 code significantly expands which basement receptacles require GFCI protection. This 23 standard. So again, all unfinished basements now require that protection, not those just within 6 feet of sinks or laundry area. The rationale: that basements are prone to moisture issues, flooding, and condensation. The expanded requirement recognizes that shock hazards exist throughout the unfinished basement spaces, not only near obvious water sources. For your inspection strategy, during basement inspection, identify all receptacles in unfinished areas. Test each one for GFCI protection using your plug-in tester. Many older homes have standard receptacles throughout the basement, representing significant upgrade opportunities. When writing your report, note that while the home may have been compliant when built, current safety standards recommend GFCI protection for all unfinished basement receptacles. This balanced approach acknowledges code evolution while emphasizing safety improvements. Finished basements with drywall, flooring, and climate control typically follow standard residential room requirements rather than the blanket basement rule, though receptacles near sinks, bars, and laundry areas still require the GFCI protection regardless of finished areas. Basically, if you're in an unfinished basement, every receptacle's got to be GFCI. He changed 6 replacement receptacle requirements. The 23 code clarifies and strengthens requirements for replacing existing receptacles. This change affects renovation work and how implications for how inspectors report on partially updated electrical system. So number 1, trigger event. Anytime a receptacle is replaced in a location where current code requires GFCI protection, the replacement receptacle must include a GFCI protection. No grandfathering. The replacement triggers compliance with current standards, even if the original installation was legal under the previous code. Inspection awareness. Look for newer receptacles in required locations lacking GFCI. Potential code violations during renovation. So if we're going into a basement and we see brand new outlets because the old ones were kind of crappy and they're not GFCI, they're no good anymore. Identifying recent replacements. As you inspect homes, look for visual clues indicating recent receptacle replacement. Clean, newer looking outlets surrounded by older receptacles, mismatched colors or styles in the same room, or modern tamper resistant receptacles mixed with older standard outlets. When you identify recent receptacles in location requiring GFCI protection, kitchens, bathrooms, garages, basements, verify they include proper protection. Document any discrepancies as potential code compliance issues resulting from renovation work. This requirement prevents incremental degradation of safety during maintenance and renovation activities. It ensures that as homes are updated, electrical safety improves rather than remains at outdated standards. So it's a little difficult because if you've had a renovation and it was done by a contractor, they had to hopefully they pulled a code. They didn't have to, but hopefully they pull a code. If they pull a code, then the town has gone in there and checked this. But if the homeowner is just replacing outlets that are ugly and they need to be GFI protected, they don't know that, and you're seeing the new outlets, you're going to call that out too. So you got to look for everything. Key change number 7, HVAC equipment requirements. The 23 NEC expands GFCI requirements for HVAC equipment in specific installations, particularly outdoor condensating units, rooftop equipment, and units installed in damp or wet locations. The new standard, HVAC equipment receptacles and disconnects may require GFCI protection depending upon the location accessibility. Inspector considerations. Check outdoor AC units, heat pumps, and rooftop HVAC equipment for GFCI protection circuits. Note that testing may be limited during occupied home inspections, but visual identification of protected types should be documented. Pay particular attention to ground level equipment where service techs work in wet conditions during maintenance or emergency repairs. So I guess your split system outside needs to be on a GFCI breaker, and any condensers, that kind of thing. Common GFCI defects.
Excuse me a minute, Jim. Wouldn't that be redundant though, because it's outside anyways? And all outdoor outlets need to be GFI protection?
Yes. It's a little redundant, but that's what they're saying.
Okay.
Yeah.
I knew that. I just wanted to ask that question.
Yeah. Common GFCI defects found during a home inspection. Understanding theoretical GFCI requirements is essential, but recognizing actual defects in the field separates competent inspectors from exceptional ones. Let's examine the most common GFCI problems you'll encounter during residential inspection. I don't know who writes this. I think I do. Viewing code. If you're viewing this as a pre-recorded event, your viewing code is AFCI 2025. We're doing good on time. Defect number 1, GFCI fails to trip. The problem, when you press the test button on a GFCI outlet or use your plug-in tester, the device should trip immediately, cutting power to the receptacle. If it does not trip, the GFCI has failed and provides no protection. This is one of the most serious GFCI defects because it creates a false sense of security. The homeowner believes protection exists, but in reality, the device offers no shock protection whatsoever. Document this as a safety concern required immediate correction. Recommend replacement by a qualified electrician. Note that the device has failed and currently provides no ground fault circuit interrupter. This is the biggest one that you have.
Hey,
We're going
Jim,
to talk.
Ed here. So
Yeah, go ahead.
My insurance company is pushing me away from the test buttons because they've had to pay so many claims where you trip a GFI in a kitchen and there's in series with other ones that maybe like you said the moose meat in the freezer, and the inspector doesn't know that that one tripped. And so they sent out this big thing about I got rid of my buttons, and talking to the master electrician up in the state here, the state electrician for Massachusetts, they recommend just using the test buttons on the GFI. They don't
Okay.
they don't recommend using the test button on our testers anymore. So I don't even have those anymore. I'm just
So
sharing.
that's interesting because when I had my kitchen remodel 5 years ago, and they came in to do the final inspection,
Mhm.
the local building inspector used a GFI tester, and one of the GFIs did not trip, but it would trip with the button. And he said, I don't really care. I want it to trip with the GFI tester. So,
Go figure that one, huh? I
right.
don't know.
But
Yeah.
I am leery about even testing them because, and I'm sure if you've been doing this long enough, you've had one that will not reset.
More than one.
Yes. So now you gotta, I mean, I like the realtors to be around because they saw I was doing my job, but now you're leaving somebody with no power and
Right.
not either that outlet or a string of them. Now
Right.
Jim's got and so if it's connected to the refrigerator, we got a big problem. So
Right.
Jim's got a great way to handle it. He's got old, inexpensive extension cords he carries with him, just to be able to power at least the refrigerator. So I still test them, but I shudder every time I do because you don't know if they're going to reset, and then
Yeah.
I
everyone's
remember
going to get pissed.
we had to move a cupboard one time because the reset was, which you're not supposed to put them back there, was behind a whole cupboard.
Yeah.
And they had to actually slide it out to get to the button to reset it again. I mean, so I don't know. I don't know what's right, really, to be honest with you. I'm
You
just
know,
Well,
sharing
you know
an
what?
idea.
I think we all just need to do what we feel we need to
Comfortable.
do.
Right. Yeah. I
Yeah.
agree.
and just to add to that, and remember Tim, who was the master electrician, told us, check the button on the actual outlet. Don't worry about the actual
Yeah.
the test device that you use that you plug in. But I'll tell you from my experience, the only thing I could add, and I know Jim, you got to get back because you got time, is sometimes when they remodel these kitchens, homeowner remodel, homeowner electrical, novice guy, they put GFIs in every outlet, and and they think, okay, I got to put a GFI, and there's only one GFI protects that whole circuit. Well, that the way that it should be, or there is a bathroom, or you go in the garage. I've tripped stuff outside, and I find them eventually. But what I will tell you, if you can't find where the reset is on the outside outlets or in the garage, go to the panel, the outlet on the side. 9 out of 10 times here in Connecticut, it's the panel out. The one that's on the side of the panel is the one that controls all those outside outlets. I mean, if you trip it and you can't find it, you look in the bathrooms, you look in the kitchen. So going back to Ed's point, if you can't seem to reset, sometimes if I'll trip the one in the bathroom, half bath, first floor, and it doesn't reset. And you're like, oh no, to Jim's point, oh my God, what's going on? There's an outlet somewhere else. And a lot of times it's the second floor bathroom that once you reset that, you put it down. And I always tell my clients, listen, you don't really need you don't need a GFI here. You just need a regular outlet. And I see that very often.
Well, yeah, but the other problem with that, Scott, was that there's outlets we test that aren't GFI, but on a GFI circuit.
Correct.
Like your kitchen, it doesn't have a GFI push button. You test it with that push button, and it trips something somewhere, right, or multiples. And that's what the insurance company was getting at. They're saying,
well, you go in the kitchen and sometimes you trip it, and here's the thing, just to show you the reason why I still use the tester. This is me. I've been doing it and I haven't had a problem. Is sometimes you go in the kitchen and there's an outlet to the left side of the stove, and then there's one way on the other side, or maybe it's not even near the stove, and you don't see any GFI outlets, but you put your tester in there, and you trip, and you hear it pop on the other side. So to me, I'll still use the tester because I want to see if that outlet is protected. But to your point, on the other ones that actually have the GFI, you can use the test button. So that's just something to think about, from all the times I've been doing it. And I've even had GFIs behind, they have the electrical panel, it's behind the wall. And I mean, I always eventually find it.
Well, Stan brings up Stan brought up two things that he and I talked about. I had an inspection in Waterbury where I tripped the outlet in the kitchen and it would not reset, and the refrigerator was on that circuit. And so I go to like dollar store, I'll pick up like 5 extension cords for $10. They're cheap. And then, I don't care if they're good or not as long as they last a day. And so the homeowner was there while we were doing it. She's like, my food's going to go bad. I'm like, no, it's not, because I came prepared and we just got that extension cord, plugged it into a working outlet, and she was fine. Everybody was okay because they knew I had to test it, but I was very lucky. My second shortened story, because we have to move along. I did a house out in Litchfield. It was about $4 to $5 million house. I was in the bathroom, which was nicer than my house. I tripped the GFI. There was no button on it. I heard it trip within the wall. The electrician had screwed up and put the reset in the wall. So there's no way to reset it. I checked every outlet in the house. I got a letter about 2 weeks later from an attorney wanting $1,500 because they had to cut that out and put a proper outlet in and rewire it, repaint. And I just told him good luck. If I didn't find that, my client
put the GFI behind the wall. That wasn't
the reset was in a junction box sandwiched in the framing.
Yeah,
someone messed up.
Yeah.
So, and I heard it right behind the wall, and I had an intern there. He heard it too, and he was like, "How are we going to reset that?" I'm like, "We're not, and we're just going to move along." So, anyways. Defect number 2, GFCI breaker fails to reset. The GFCI breakers and electrical panel should reset after being tripped during testing. If the breaker won't reset and won't stay on the on position or immediately trips again, this indicates a problem, either with the breaker itself or with the circuit it protects. Potential causes: there's a failed breaker, ground fault on the circuit, damaged wiring, moisture infiltration. Inspector response: document the failure to reset. Note that you cannot fully evaluate the circuit when breakers won't reset. Recommend electrical contractor evaluate, diagnose, and repair. Defect 3, no power to downstream receptacles. GFCI receptacles can protect additional downstream outlets on the same circuit when properly wired. However, if the GFCI is miswired downstream, outlets may lose power even when the GFCI hasn't tripped. During your inspection, if you find outlets near a GFCI receptacle with no power, test the GFCI. If the GFCI hasn't tripped, but downstream outlets are dead, this indicates miswiring, typically incorrect line load terminal connections. This defect is common in DIY installations and during receptacle replacements by unqualified individuals. The GFCI might still protect itself, but fails to provide protection to connected outlets. Defect 4, reverse polarity and open grounds. Reverse polarity occurs when hot and neutral wires are swapped at the receptacle. Open grounds occur when the equipment grounding conductor is missing or disconnected. Both conditions can prevent GFCI from functioning properly. Reverse polarity. Your plug-in tester will indicate reverse hot and neutral conductors. GFCIs may not trip properly with reverse polarity, compromising protection, requiring rewiring by an electrician. Open ground. While GFCIs can function without equipment grounds, open grounds indicate incomplete electrical safety systems. Document and recommend evaluation, especially in conjunction with other wiring defects. So I run into this when you do bathrooms. Your tester says it's non-grounded, but it's GFCI. Your tester will not trip it. You're going to have to push the button. Then what do you tell the client? You tell the client that the outlet's not grounded, but you are protected from electrical shock, but it's not complete electrical safety. So you probably want an electrician look at it, but in the meantime, it's not what I would call an emergency or a deal breaker or anything like that. The outlet is protected, but not, it's not properly. You can't properly test it with a tester. Defect 5, bootleg grounds. A bootleg ground, also called a fault ground, occurs when someone intentionally connects the grounding terminal to the neutral terminal inside the receptacle box. This makes the 3-prong tester show correct, even though no actual equipment or grounding conductor exists. Bootleg grounds are dangerous because they can energize equipment and metal surfaces during certain fault conditions. They also prevent GFCIs from operating correctly during ground faults involving the ground conductor. Detecting bootleg grounds requires careful testing. If you see a 3-prong receptacle in an old home with 2 wires, ungrounded circuits, investigate closely. Your advanced tester can help identify these dangerous conditions, modifications. This is kind of we're not, at least I'm not pulling out an outlet to check what's going on there. So defect 6, missing in-use covers. Exterior GFCI receptacles require weatherproof in-use covers that protect the outlet even when a cord is plugged in. Standard flip covers that only protect the outlet when it doesn't, when closed, don't meet current requirements for exterior outlets. In-use covers feature deep boxes that fully enclose plugs and cord connections, preventing water infiltration during use. Missing or damaged in-use covers expose GFCIs to moisture, potentially causing corrosion failure or shock hazards. This is an easy catch during exterior inspections. Document any outdoor GFCI with standard flip covers or damaged in-use covers and recommend upgrade to proper waterproof protection. I personally hate these in-use covers because they're very difficult to open, and I've broken one or two of them just in frustration, but it is required. Defect 7, non-upgraded renovation areas. Kitchens and bathroom renovations often include cosmetic updates, new countertops, cabinets, and fixtures, without corresponding electrical upgrades. This creates situations where brand new granite countertops are served by decades-old non-GFCI receptacles. Renovation work frequently triggers permit requirements and code compliance for affected systems. Outlets in renovated spaces should meet current codes, even if other parts of the home don't. What home inspector's response should be is note the recent renovation and verify electrical updates match. Recent remodel kitchens, baths, or outdoor spaces lacking GFCI protection may indicate incomplete permit work or unpermitted renovation. In all my reports, I put that it's the client's responsibility to check to see if permits were pulled on any renovations or other work completed on the home. I do not want any part of that. Defect number 8, shared neutral issues. Okay. Multi-branch circuits share a neutral conductor between two hot conductors. These circuits are common in older homes and remain code compliant when properly installed. However, adding GFCI protection to shared neutral circuits requires special handling. The problem: standard single-pole GFCI breakers won't work correctly on multi-wired circuits sharing a neutral. The GFCI will detect an imbalance and trip repeatedly, even under normal operation. This requires either two-pole GFCI breakers or rewiring to eliminate the shared neutral. As an inspector, you may encounter situations where someone attempted to add a GFCI protection to a shared neutral circuit, resulting in nuisance tripping. Document the configuration and recommend electrical contractor evaluate for proper GFCI implementation. Defect 9, incorrect GFCI protection coverage. Sometimes GFCI receptacles are installed but protect the wrong outlets. You might find a bathroom GFCI protecting garage receptacles or a kitchen GFCI controlling outlets in a bedroom. This occurs when load line connections are confused with circuits were modified after initial installation. Testing strategy: test every receptacle in required locations individually. Don't assume that because one GFCI exists nearby, all surrounding outlets are protected. Documentation: it's easy to test a kitchen outlet, look to see that they're all GFCI, think that they're all going to work properly, but you got to do each one. Documentation: note which outlets are GFCI protected and which aren't. Identify patterns suggesting miswiring or load line confusion. Recommendation: recommend electrical contractor evaluate the trace circuits to establish proper GFCI protection for all required locations. You know, if you have a 5,000 square foot house or any house and your reset is in your GFCI protection is in the basement on a circuit breaker. My clients walk in and they're 75 years old. I'm telling them that they might want to call an electrician to move that reset to the kitchen because they might not want to walk downstairs if it trips. So that's something also that I do put in my reports depending upon client mobility and age. If you're young, you don't mind going down there. Nuisance tripping. GFCIs that trip frequently without cause create frustration and may lead homeowners to bypass protection. Nuisance tripping can result from several causes. As we talked about, moisture infiltration, damaged appliances, deteriorating GFCI devices, or improper circuit configuration. While you may not observe nuisance tripping during the inspection, homeowners often mention it. Document any reports of frequent GFCI tripping and recommend evaluation to identify and correct the underlying cause rather than bypassing protection. emphasizing that while nuisance tripping is inconvenient, it often indicates a real problem requiring attention, not a reason to eliminate GFCI protection. So we're not going to see that during the inspection, not always. I came across it one time. I reset and it tripped, reset, retripped, and it was because of water in the basement. All right, here's a big one. Misconceptions about GFCI interrupters. Outlets can lead to misunderstandings regarding their purpose, operation, and effectiveness. Here are some misconceptions about GFCI outlets. Number one, GFCI outlets provide protection against all electrical hazards. While GFCI outlets are crucial for protecting against ground fault circuits, they do not provide protection against other types of electrical hazards, such as short circuits or overloads. The GFCI outlets are designed specifically to detect and respond to ground faults, not to address all potential electrical dangers. GFCI's outlets eliminate the need for proper grounding. As we talked about, you've got to have proper grounding. Grounding is a separate safety measure that protects against electrical faults and ensures that excess electrical current is safely directed to the ground. GFCI outlets provide additional protection, but they do not replace the need for proper grounding. As we talked about in the bathroom, that is non-grounded, but it's GFI'd. All tripped GFI outlets can be reset immediately. Well, Scott said when testing GFCI outlets, if it cuts out power to the connected devices, it is common misconception that all the GFCI outlets can be reset without investigating the cause. It's essential to determine the reason for the trip, such as a ground fault or faulty equipment. Before resetting the GFCI outlet, simply reset a tripped GFCI without addressing the underlying issue could lead to continual electrical hazards. So someone's washing their hair, there are cords in the in the sink, and they keep tripping it. You got to find out why it's happening. All outlets in a room are GFCI protected if one outlet is GFCI. We talked about that. They're not always. GFCI outlets last indefinitely and do not require testing. So we talked about this. GFCI outlets, like many electrical devices, can deteriorate over time and become faulty. It is a misconception to assume that the outlet will last indefinitely without requiring testing or maintenance. Periodic testing of a GFCI outlet is necessary to ensure their proper functioning. The built-in test buttons on a GFCI should be pressed regularly to confirm that GFCI protection is operational. GFCI outlets can never trip or malfunction. While GFCI outlets are reliable safety devices, they can still trip or malfunction under certain conditions. Factors such as power surges, wiring issues, faulty appliances or devices, or moisture ingress can cause GFCI outlets to trip and become non-functional. Regular testing and proper maintenance can identify any potential issues and ensure continued effectiveness of these outlets. The power of clear communication. How you frame GFCI findings can significantly impact client understanding and response. You want to avoid inflammatory language like dangerous or life-threatening if missing GFCI protection in older homes. Instead, focus on explaining that safety standards evolved based on improved understanding of electrical hazards. Emphasize that GFCI upgrades represent proactive safety improvements rather than emergency correction or imminent hazard. This balanced approach maintains your credibility, helps clients prioritize improvements appropriately, and provides and positions GFCI upgrades as valuable enhancements rather than to fear-driven urgent repairs. So we had one the other day, first-time buyer, she's 25 years old, they're all two-prong outlets in the house, and she has no money. So like, what are you gonna do? I'm like, well, you're gonna do breakers, you're gonna do, you're gonna change everything to a three-prong, and GFI in the bathrooms and the kitchen, and you're going to do the outlets that you can in the living room and bedrooms that you're going to use commonly. You have to do some things, but you don't have to do everything right away. How the 23 changes affect your inspection reports. So these updates fundamentally change how home inspectors approach GFCI evaluation and reporting. Your inspection report should reflect current safety standards while acknowledging that older homes aren't required to meet retroactive code compliance. So we're going to increase our documentation, expect to report more instances of missing GFI protection, enhanced recommendation, frame the GFCI upgrade recommendations as safety improvements rather than code violation. Use phrases like not required when built, but upgrading recommended for enhanced safety. Client education. Help clients understand that electrical safety standards has evolved. Like we talked about, properties lacking current GFCI protection coverage aren't necessarily defective. They simply represent opportunities for safety enhancements. More reporting needed for older homes. The expanded GFCI requirements mean that virtually every older home you inspect have areas lacking protection under current standards. This creates consistent opportunities to demonstrate your knowledge and provide value through safety recommendations. When evaluating homes built before 2020, you'll commonly find standard receptacles in unfinished basements, outdoor deck outlets, appliances on unprotected circuits. Document these conditions clearly and explain the evolution safety standards to your clients. Your reporting should be balanced accurately with context. Avoid creating alarm about conditions that were code compliant at the time of the construction. Clarify your narratives. Effective communication about GFCI requirements and recommendation requires careful crafted narrative language. Your inspection reports must be clear, accurate, and helpful without overstepping your role as an inspector. As home inspectors, we are not code enforcement officers. We evaluate homes against current safety standards and common practice, providing recommendations that help clients make informed decisions about their property. Narrative structure, the 4 elements. So I've been spending the last week updating my narratives and moving everything over to the 1, 2, 3, 4. You want to observe, factual description of what you report, what you find during the inspection, objective, specific, and verifiable. Include locations, device type, and testing results. Implication, explain why this matters. What risk does the defect create? How does it affect safety and functionality? Keep it proportionate to actual risk. This implication is really big, and I've said this before in other webinars. It has helped me so much cut down my phone calls, especially from agents. There's a lot of new agents who aren't being trained very well. And if your inspection just reads, there's no GFCI in the kitchen, recommend electrician evaluate and make necessary upgrades. Well, why? They'll call me up and they'll go, well, why? Now with the implication, they can read why, and it cuts that phone call out. So you're gonna make a recommendation, specific action for correction, who should address it, electrician, handyman, what needs to happen, repair, replacement, evaluate. I don't go in for the repair or replacement. I just go in for the evaluate. I recommend that a licensed electrician evaluate the outlets or non, whatever it is. And at that time, have them make a recommendation. I'm not telling anybody how to fix anything because there's 19 different ways to fix it. Limitation, acknowledgement of what you couldn't verify or test. Note if further evaluation is needed. There's a 400-pound chest next to the wall that you can't move. You're not moving it. And there's an outlet behind there. You're not testing it. So a good limitation is going to have in there that there's some furniture and homeowner belongings were in the way. Effective report language examples, historical context. This home was built in 1985, when GFCI protection requirements were less extensive than current standards. Several receptacles lacked GFCI protection that would require new construction. Safety focus. For enhanced electrical safety, consider upgrading all unfinished basement receptacles to GFCI protection. While not required when the home was built, this improvement aligns with current best practices. Specific recommendations, we're going to say that the outdoor receptacles on the rear deck lacks GFCI protection. Current electrical standards require GFCI protection for all outdoor receptacles, regardless of elevation, recommending upgrading for shock protection. Balanced approach, several kitchen counter receptacles were not GFI protected. GFCI protection has been required for kitchen countertop outlets since 1987. Recommend evaluation upgrade by a qualified electrician. Also, the islands in a kitchen need to have that protection and to have an outlet. Here's a sample narrative for a failed GFCI test. How are we doing in time? Observation, we're doing really good. The GFCI receptacle on the kitchen countertop near the refrigerator did not trip when tested using a built-in test button and plug-in GFCI tester. Implication, this GFCI device has failed and provides no ground fault protection. The receptacle remains energized during fault created shock hazards. Recommendation, recommend immediate replacement of the failed GFCI protected by a qualified electrician. Verify proper operation after replacement. Limitation of inspection. Tested is limited to accessible GFCI devices using standard methods such as built-in test buttons and plug-in testers. Concealed wiring panel level GFCI breakers that are not readily accessible, and devices located behind finished surfaces may not have been tested. Missing GFCI protection. So we have our observation of 2 receptacles in the unfinished basement that are without protection, the implication that it's a safety issue, the recommendation is upgrading, and the limitation is inspection of the receptacle by limited to visual accessible outlets in the standard testing method. So we're not taking out the outlet, we're not using any weird kind of testers. Not all circuit concealed locations or devices hidden behind finished surfaces could be verified for GFCI protection during the inspection. Well, I moved into the house and you didn't test 6 outlets in the basement. And you should have pictures. When there's storage, you want to take as many pictures as you can of all that storage, because that's going to be the, you're going to put in your report that it was. I have a styles and materials sort of like at the beginning of the report. Is the house finished? Is it fully furnished? But then all my limitations are in there about storage. Okay, so we've covered the essential aspects of GFCI protection in residential home inspections, from basic operation to the latest 23 NEC requirement. So we're going to address any questions. The key takeaways: test everything, know your locations, balance your reporting. You want to stay current, upgrade your safety narratives. I've been doing that for the last couple of weeks. The stuff that we covered today. You can rewatch this. If you have any questions, you can just email me. But I know that I've been going through my reports and definitely upgrading my GFCI comments. And we want to remember your role. We're not code enforcement officers. We're going to, just explain what we have to. We're not going to be going over our standards or anything like that. We want to frame our GFCI recommendations as opportunities for safety enhancement. That's the most important thing. And I'd like to thank you for attending tonight. We're at 7:56, so if we have any questions, this is our logo that you can put on your website or any material that you have. You're going to be able to find that under the logo section of our website, and the password is Cornerstone because that's a password protected page. I think in 2 weeks we have inspecting 100 to 300-year-old homes, and we're going to have some videos in our presentation because I've actually inspected a couple of 300-year-old homes this month. So I took a lot of videos of basements and attics, so we'll have some real life video, so that'll be exciting. Do we have any other questions or concerns? Scott, do you have anything that you'd like to add?
No, that was good, Jim.
Ask one question.
Yeah, sure.
So you said that ungrounded outlets can be GFCI protected.
No.
Okay,
Well,
I thought I heard you say that, and
yeah.
if you didn't, that
Yes.
makes sense to me because I didn't realize that could be done like that.
No, I did say that. So if let's say you're in a bathroom and you plug your tester in and it shows that it's not grounded and it's GFCI'd. You're going to press it's a GFCI outlet. It's got the 2 buttons, red and black, whatever color they are, if they're clear, and you test it, it's not going to trip. Okay. So it's not grounded. However, the GFCI protection from water, that interrupted supply of electricity by moisture, is still there. And that's going to trip the outlet. Okay. It's not going to help, like we talked about, it's not complete protection because the ground protection does other things for defective appliances and stuff like that, like we talked about. But if you press that button physically, it will trip. And then you have to, you just reset it. But it does protect the outlet, even though it's non-grounded, will protect you from electrocution from water intrusion or moisture. So if you're
Right,
blowing
if it's connected. What about a surge protector in like a living room on grounded outlet? That's not protected in any way, right? That's just an extension cord at that point.
Extension cords are not ground protection, right?
No, I meant the the what do you call it? The ground fault strip.
No.
If that's plugged into a non-grounded outlet, that's just becomes an extension cord.
Basically, yes.
Okay.
Well, that's where you see these outlets, and I'm going to say hospitals, or sometimes badly will say GFI protected ungrounded, outlet ungrounded.
Yeah, I've seen that too. Yeah.
Because it's just sensing a ground fault, not necessary.
But one of the most common things I see in these houses is people who put the strips down. I'm having what do you call those protection strips?
Surge
The
protect.
plug-in GFCI strips, the
Are you
ground
talking
fault
about the
strip.
little blue strips that they put on?
The ones that come with 5 or 6 plugs. I'm just having trouble thinking of the damn name. But it's an extension. If you plug it in, it's got the GFCI breaker in it, and then it's got 4 or 5 outlets. The surge protector, that's what I'm talking about.
Right.
So the surge protector, I see them plugged into ungrounded outlets all the time for their computer, their TV, and they think they're protected. But those, I tell people, those are not protected because the outlet's not grounded. Is that correct?
Correct.
That's correct.
All right.
That's correct.
Well, you see people take 2-prong outlets all the time, and some homeowner goes to a Home Depot. I see it all the time. Yesterday, the whole house was ungrounded. So the 2-ply, back in when I was younger, you had just 2 prongs. So the old BX was the ground, was the bond, and now they go pull the outlet out. They got the hot, the neutral. They put in a 3-prong outlet, and they don't ground it to the box or buy the self-grounding outlets. And they go, oh, now I can plug in all my stuff. And theoretically, the appliance ground, if it's ungrounded, it's
right. Okay. I just wanted to be clear on that. I'm sorry.
Including your surge protector.
No worries. It's a good question.
Thank you.
Thank you. Okay, so we're all set. I will get certificates out, like I said, and if you have any additional questions, please feel free to email us and we'll go from there. Stan, you all set? You have anything you want to add?
I am all set, Jim.
Okay.
Nice job.
Fire up that burn.
Thank you, guys.
Thanks for attending, gentlemen and women.
Thank you.
Good night, John.
Gentlewomen.